Greetings to everyone. So last class we discussed about the introduction to stereochemistry and then classification, and now we are going for its optical activity. So optical activity is considered for only chiral molecules. So only chiral molecules exhibit optical activity. So you'll ask me now, what is a chiral molecule? So, a chiral molecule is a molecule which has a carbon with four different functional groups attached to it. Okay, then only it can exhibit chirality. Okay, so a chiral optical activity is the ability of a chiral molecule to rotate the plane polarized light measured using a polarimeter. Okay, so what is that? That is nothing but optical activity is nothing but a chiral molecule rotates the plane of polarized light in clockwise direction or in anti-clockwise direction. Okay, so that is called as optical activity. So what is plane polarized light? So light that has been passed through a nickel prism or other polarizing medium so that all the vibrations are in the same plane. So you can see here the polarized light, it has vibrations in the same plane. Whereas you see here non-polarized light, it goes in any of the direction. Okay, this is in the one direction. This is in any of the direction. Okay, so plain polarized light is passed through a nickel prism. Okay, now coming to the instrumentation part of the optical activity. So we have a polarimeter. So a polarimeter is an instrument used to measure optical activity. Okay. So a simple polarimeter consists of a light source, polarizing light, sample tube, and analyzing lens. So you can see here, this is the light source. Okay, when light is passed, okay, using this light source, the polarizer, okay, it polarizes the light. Okay, then the polarized light is transferred to this sample tube. Okay, so this sample tube, and then there is an analyzer fixed here in order to check whether the light has been directed or not. Okay, so if it directs the plane polarized light in clockwise direction or on anti-clockwise direction, and then we have our necktie, which is going to see all these things in a polarimeter. So a polarimeter consists of a light source, a polarizing lens, then a sample tube, and then analyzing lens. So the sample is kept in this sample tube. Okay, and then light is passed through this light source through the polarizer. Okay, then the plane polarized light may be that will rotate the plane polarized light to the clockwise direction or anti-clockwise direction. So this can be observed in this polarimeter. So we have already used nickel prism, right? Then, if the optically active compound rotates the plane polarized light in a clockwise direction, okay, suppose it rotates the plane polarized light to in a clockwise direction, then it is called as plus or small d. So please don't get confused with the capital D. We are going to deal with this capital D also in our next coming classes. Okay, so it is represented as plus or D, that is small d. Okay. Then levorotatory, that is an optically active compound that rotates the plane polarized light in a counterclockwise direction, that is anti-clockwise direction. So that is called as levorotatory. So if if the compound rotates the plane polarized light in a clockwise direction, it is called as B, or it is given as a plus sign. If it rotates the plane polarized light in an anticlockwise direction, then it is given a negative sign and it is written as small l. Okay, we have capital L also. As I told you, we'll discuss it in next classes. Okay. So the angle of rotation of plane polarized light by an optically active substance is proportional to the number of atoms in the path of the light. Okay. So what is it given? So the angle of rotation of plane polarized light by an optically active substance is proportional. So the angle of rotation is directly proportional to the number of atoms in the path of the light. Okay. So example is given here, that is lactic acid. If you see lactic acid, you can see the OH group is present on the right hand side. Okay, so it is given as plus sign or small d, and then if it is on the left hand side, OH group is present on the left hand side, it is given negative or small l. Okay, so you can that means this lactic acid has rotated the plane polarized light in a clockwise direction. Okay, so the same sample, if it rotates a plane polarized light in anti-clockwise direction, it is given as minus, okay, or written as small m. Okay. Now coming to the specific rotation. So actually this polarimeter and optical activity is used to find out the specific rotation. Okay. So the angle of rotation of plane polarized light by 1 gram per centimeter cube sample in a 1 decimeter tube is called as specific rotation. So how much rotation it is making? So that is measured in terms of specific rotation, and it is the angle of rotation of plane polarized light by 1 gram per centimeter cube sample in a 1 decimeter tube. Okay? And it is represented as alpha D. Okay? Where D is the sodium lamp and its wavelength is given as 589 millimicrons. Okay? Now this alpha D is equal to alpha by L into D, where alpha is the observed rotation. So we are seeing through our eye, through the polarimeter, how much rotation it has been made, either clockwise or anti-clockwise. Okay? Then L is the length in decimeter and B is the concentration in grams per cc. Okay. So we have alpha by L into D. So the specific rotation can be calculated using the formula, that is alpha D is equal to alpha by L into D. Okay. So he has given examples for alanine and lactic acid. So for alanine, positive, that is alpha D is equal to plus 8.5, and for levulactic acid, it is given as minus 3.8. Okay. So these are the calculated values. Okay. So which has been given. Now, specific rotation depends upon the nature of the substance. Okay. So wavelength of the light used, right? Because we are using sodium lamp and lambda is 589 micrometers. So it depends upon the wavelength of the light used, and then concentration of the solution, thickness of the layer, nature of the solvent, and temperature at which the experiment is conducted. Okay, so specific rotation depends on all these factors. That is, Nature of substance, wavelength of light used, concentration, then length, that is nothing but thickness, and then nature of solvent and temperature at which the experiment will be conducted. Okay? So this is about the optical activity. So optical activity is nothing but a plane polarized light, okay, is rotated, okay, either clockwise or anti-clockwise. If it is then it is measured using polarimeter, which has light source, polarizing lens, sample tube, and then analyzing lens. If it rotates a plane polarized light to the anti-clockwise direction, it is called as D or positive. Then if it is rotating the plane polarized light in anti-clockwise direction, it is represented as small l and negative. Then we have specific rotation. How it is calculated? It is nothing but alpha by L into T. Right? So this is about the optical activity. Thank you.